If humanity doesn't get it, humanity is not gonna make it. Now I can complete Einstein's theory of gravity and actually have a clear path to how to control gravitational field. Emptiness is the form, and that the form is emptiness.
I'm MAİA and I'm so excited right now because I'm with a genius and we are going to witness a wonderful and mind-blowing conversation with Nassim Haramein. Nassim Haramein has been exploring the nature of the cosmos for 35 years by integrating different disciplines, and he is one of the pioneers in uniting knowledge, science, mathematics, philosophy with the quantum world, and it's a great pleasure to be here with you. Welcome, Nassim.
Thank you.
How are you, Nassim?
I'm good. It's been a lot today, but I'm good. Yeah.
It was a wonderful conference, and now my brain is full of electrons, protons, black holes.
Oh, yes.
And I have your last papers here.
Yeah.
And your last papers are groundbreaking because you wrote something about the origins of the mass and the nature of gravity.
Correct.
And you claim something mind-blowing.
Yeah, I claim that that mass comes from a fundamental field of energy. See, in physics currently, mass is not explained. Mm-hmm. There's the Higgs mechanism, but it only predicts 1% of the mass, the proton. And the proton is the nuclei of the atom that provide most of the mass for all the universe. Mm-hmm. And so, and the electron provides a little bit of the mass, very small amount. And I can show both for the proton and the electron, although I don't treat the electron in this particular paper, that mass actually comes from quantum vacuum fluctuations. Mm-hmm. Now, you might ask, what is quantum vacuum fluctuations?
Yes.
So quantum vacuum fluctuations, unlike what's being taught in universities, which is wrong. Even ChatGPT is wrong about this. I have to, correct it every time. It is an electromagnetic fluctuations that is called zero-point energy. Mm-hmm. And it was called zero-point energy by Max Planck, the founder of quantum mechanics. Mm-hmm. So let me explain a little bit how this came to be, this discovery. Max Planck was asked to make a better light bulb, to improve the light bulb. At the time, the little filament of the light bulb was burning out very quickly, and they were trying to figure out a way to make a better light bulb. So then they asked Max Planck, which was a famous physicist at the time, to see if he could help. It was the Bureau of Standard in Europe that asked. Max Planck had already been looking at thermodynamic equations, so trying to figure out the amount of radiation that comes from matter when you heat it up, when you give it energy. So he was making little black balls, because black absorbs energy. So he was making little black balls with a little hole in it and trying to figure out what is the frequency related to a certain temperature. So on the graph, it would be frequency and temperature. Mm-hmm. And the equations of the time said that at high temperature, there would be an infinite amount of ultraviolet radiation that should come off the little elements of the light bulb. And that was not what we were measuring, what they were measuring. So there was a problem. And so Max Planck was trying to solve this problem, and the only thing he could come up with was to put a little free parameter, a little fudge factor in the equation that he called h. Like he put this constant h in there that became Planck constant. But the thing is, when he put this constant in there, the equation is describing a cavity that's oscillating. So think of like a proton, you know, the nucleus of the atom, like being a little cavity that's, and it's absorbing energy, right? They didn't have photons at the time, but electromagnetic energy was being absorbed, and then it would radiate electromagnetic energy as this little cavity was spinning, like it's called a harmonic oscillator. And so when he put the H in the equation, it said that the energy that was coming in and the energy that was coming out was not continuous, it was in packets. And so that was very strange to him. He thought this has got to be wrong, right? And Einstein eventually found that these packets are the little packets that knock out electrons and makes the photoelectric effect, like solar panels, you know. And he got the Nobel Prize for that. And he called these little packets photons. And then Bohr found that, you know, the electron shells would jump from one electron orbital to another when it absorbed these packets as well. And so that was the start of quantum mechanics. The only thing is when he calculated the energy of this equation, right, which is the temperature against the frequency or the energy of the system, when he put the temperature at 0 in the equation, 0 Kelvin, where everything should be frozen, you know, that's much hotter than Canada, much colder than Canada, you know, that's like frozen, like there should be no thermal agitation. The equation says that there's infinite amount of energy in the little cavity when it should be 0. And so since the equation gave all the right answer for everything else, and then was confirmed by Einstein and Bohr and all this, you know, Planck just called it zero-point energy.
During the conference, I took some notes. You said that the universe renews itself within the span of a single Planck time. You talked about the black hole also and the zero-point energy together. You combine them with the information.
That's right. I showed that actually a black hole is the zero-point energy that is in coherent mode in that region. It's not accumulation of mass. Mass is actually zero-point energy being coherent in that region, in that cavity that produces the mass. So it's a completely different approach, although it's using all the things that are already there. I'm not inventing new things. I'm just reorganizing what was already there.
And was it that Einstein couldn't realize when...
So basically Einstein tried to make the little proton a black hole because he was trying to unify physics. Okay? And so he used his equation and he tried to apply them to the quantum world, to a proton. And so he used general relativity, Einstein field equation, which predicts black holes, okay, and applied them to a proton. But when he did that, the equation gives a radius, but the radius was like 10 to the minus 54 meter, which is like billions of times smaller than the Planck scale. Like it's like incredibly small, and so it didn't match the measurement of the proton or what we thought the proton is. So at the time, so he said, oh, that doesn't work. This was Einstein-Rosen paper in 1935, and it predicted wormholes. And this is how we get wormhole theory. But when people think of wormholes, they always think of wormholes in the universe somewhere. But actually Einstein described this to describe atomic structure. And I realized that they had made, and since then nobody noticed, that they had made an error. when you do the calculation, instead of saying how small do the proton have to be a black hole, you actually say how much mass do I have to put in, how much energy I have to put in this proton for it to become a black hole. And if you do that, you realize that the energy you had to put in is exactly the energy of the nuclear force. Meaning that the nuclear force is because the little proton is a mini black hole. The force that holds the protons together is actually because the proton is a little black hole.
And gravity?
Yeah, it's the gravity of a mini black hole the size of the proton. And the energy you put in there, you get exactly that energy from the zero point energy inside that cavity. So it all worked together.
Then mass is the cause of the black hole?
Yeah, the mass, but the mass, all of a sudden the mass is not something you just put in the equation, just assume the mass. Now the mass is coming from zero point energy fluctuation of this fundamental field. Now you can show that mass is emergent, is an emergent property of this fundamental field of zero point energy. You see, because otherwise there's no source for mass.
Yes, and you are saying that everything is in interaction between each other constantly. The 0 point area is full of energy, you say?
Everything is full of energy, yeah. You know, the space between you and me right now is full of energy. Like there's electromagnetic waves, like radio waves, there's our cell phone, you know, microwaves, there's like all kinds of things. There's like background radiation from the galaxy. Well, there is 0 point energy, but it's fluctuating billions of times smaller than the atom, so it's an energy that's there, but we don't directly measure it, but we measure it in laboratory now.
Here, 3 days ago, you messaged an X message. You said, yes, we can power the world from empty space. 0 point energy is real, tech is catching up, we are not just dreaming, we are doing it. And how close is the humanity to that?
Oh yeah, it changes everything. First of all, we realized that actually there's a field of information, and that field, Bohm and De Broglie had come up with it, is an alternative to this description of the Copenhagen interpretation of quantum mechanics, and so like you realize there's a field everywhere, and that field is actually making the atoms you're made of, and you're interacting with that field, and this is a non-local field, so that means everything you do, the field is recording it. Everything you do, the field is changing, and it's changing everything in the universe.
It's amazing.
It's remarkable. So now all of a sudden you feel like connected instead of disconnected. You feel a fundamental relationship to the whole instead of feeling like you're isolated from the whole. So that changes like fundamentally in your consciousness, but as well, then you can go and like, when you understand how that field functions, you can go and make technology in a laboratory to extract energy from that field.
Yeah. And do you think that humanity is ready for infinite energy?
I think humanity, I don't know if it's ready, but I think that if humanity doesn't get it in the next few years, humanity's not going to make it. There is no other way. We're not going to save the world with solar panels and, you know, like windmills or even fusion devices. You know, they've been trying to do hot fusion for some like 5 decades, and every decade they say, oh, it will be there in 10 years. We've invested billions and billions and billions of dollars, into these devices. Not one has produced 1 watt of usable power, and so on. And that's not the case for extracting zero-point energy. There's been successful devices. And so what I'm saying is that this is an energy we need. It's going to decentralize all energy. Your cell phone will be making its own energy. Your car is going to be making its own energy. Your house is going to be making its own energy. You'll be able to have energy anywhere you want. We can greenify deserts. We can change everything. Like all we can.
It's freedom.
It's freedom, complete freedom, and our capacity to repair the damage to our planet becomes exponential.
And I want to ask, what are your dreams in your physics? For example, writing equations for which dream? Because I think you have a great contact with the zero-point energy, and you can pull the information from there.
I think my dream is to bring this to the world, bring this energy, but as well bring the theory to the world and for the physics community to actually understand this, because it's gonna change the way we think about ourselves, about the universe, about how things are. Eventually it will produce gravitational drives, because energy is just the first application, but then there's gravity control that comes right after, and gravity control is gonna allow us to like lift off the planet, and you know, without rockets, because we're not gonna colonize our solar system with rockets. That is not, that's not possible. I'm sorry, Elon, it's not gonna happen that way. It's not reasonable. You would have to have thousands of rockets leaving in a window of a few weeks, you know, every 2 years, to just put a few hundred people on Mars. I mean, it makes absolutely no sense. That would destroy the environment. You know, there's very potential clear path to controlling of gravity. We built all of our civilization because we learned to control electromagnetic fields, and that's how you're filming me right now, why there's lights in the room right now and all this. And the next step for humanity is to control gravitational field. But just as with the electromagnetic field, until you have a solid theory on how it works, then you can't engineer the device to do it. And now I can complete Einstein theory of gravity and actually have a clear path throughout to control gravitational field. Yeah. So now you can imagine, you can have ships bringing people into space every day with almost zero impact on the environment. You can go orbit Jupiter for the weekend. This is not crazy. You know, if you went to the Wright brothers like the week before they flew the first plane, and you said to people in the village, oh yeah, you know the 2 guys on the end of the road there that have a bicycle shop? They're gonna actually put like 1,000 of pounds of material up in the air with them on it just by pushing wind. They would have said, you're crazy, you know? And actually at the time there was hundreds of physics papers published in the best journals of the time, mathematically proving that it was impossible for anything heavier than air to lift off the ground. And, you know, 2 guys in a bicycle shop, you know, with a bunch of like bicycle gears and chains and stuff, and 2 motors lifted off the ground, right? And this proved them. And so, you know, it sounds outrageous to think that you could have a gravitational drive right now. But as soon as it's done, then it will become everyday occurrence, just as much as you don't think twice right now. You get into a plane that weighs thousands of pounds.
It is still strange for me.
Yes, it is a little bit strange. But still, you get in there, you go across the world, you know, it's normal. You know, that was unthinkable only 100 years ago.
Nassim, I want to make it critic. People are very hard to change, and even the scientists, I think, because they are trying to make science without dreaming, and without dreaming, science cannot be made.
Yeah.
You want to find something new.
Exactly. Well, you know, scientists love science fiction in general. Physicists, definitely. Many physicists are like Star Trek fans and all this. But the thing is that the educational system stops everybody from dreaming. They tell you your dreams are invalid, forget it, shut up and calculate. And you know, they stop creativity, they stop imagination. Although the greatest physicists told us imagination is more important than facts, and so physicists are not given the opportunity to dream. If they start dreaming, they get in all kinds of trouble.
Yeah, also in their universities, and also maybe their papers won't be accepted, or
their papers won't get published. Their peers will make fun of them. They will have a hard time getting good work in universities, or they will be demoted, or they won't be able to get tenure. You know. Yeah, exactly. Then you become the black sheep. Nobody wants to work with you. Nobody wants to cite you. But I'm an independent, so I didn't care. I'm like, okay, whatever. You don't want to work with me, that's fine. But I mean, it still hurts me. It makes it very hard for me to publish. It makes it very hard for me to, you know, like many physicists now, especially now that I've published some of these new papers, I have one in peer review right now, you know, I have many scientists that, you know, communicate with me in the background, but they want to, in private. But they can't come public, because if they come public, their institutions and who they work with and all this becomes a nightmare for them. So it's a big problem.
Everywhere, and the future is for dreamers, I think, and it won't change. But for example, people like Ibn Arabi and thousands of years before taught nothingness, emptiness is the fullness or the potentials of the creature. And now you are, and the scientists like you are proving this.
Yeah.
And is there a place that our consciousness is in interaction of that information, but it is the future information? Or the information is always there and we have inspirations or we have dreams with it?
Yeah, the information is always there, and we're interacting with it. You know, that you're right, like many ancient civilizations. You know, a few weeks ago I was in Japan for a physics conference, and I went to visit a beautiful temple in the middle of a cemetery of all the ancient samurais, and there's a famous monk that went in that temple and never came out, and his doctrine of this monk was that emptiness is the form, and that the form is emptiness. So this is like, you know, like this song that they repeat in Japanese, and I'm not gonna try to say it in Japanese because it's not gonna be good. But it's this song that emptiness is fullness, or is the form, and the form is emptiness, and so it really is, you know, like a very big change in your understanding that, like, there is actually nothing that's actually empty. There's always energy, there's always fullness, and that fullness is what's making the form, it's what's making the material world, and you're in contact with it. you have a constant interaction with it, and you can be aware of it or not. And when you're aware of it, then you become like a vacuum engineer. You can mold it.
Like you activate your black hole because the information comes and you get out the information.
Yeah, you activate your awareness. You turn your senses from the outside to the inside. You go inside the atomic structure of your being and you connect with it. And when you do, then like you become aware of its flow, and then you learn to get better at making it flow. You know, like many ancient civilizations, they had chi, mana, you know, prana, all kinds of names for it, and they were teaching people how to manipulate the energy. And so you can do that, and you can do it for health, for you know, having more of an impact on the world, and so on.
For new ideas,
or for technology to make energy or control gravity.
I think Tesla has some words like that, but I don't remember everything is vibration, and he was saying something like that.
Yes, exactly.
Vibration.
Yeah, and he knew, he called it the ether. He had taken that from Maxwell. Maxwell described the electromagnetic field as riding waves on an ether, luminiferous ether, he called it, and it was removed later on. But that was the inspiration for Einstein's space-time, was the ether, and then it came up again, as I was saying, in quantum mechanics. You know, the zero-point energy. This is all the same thing that just get called all kinds of different ways, you know, along
the names are different, but the material is the same.
Is the same, yeah.
And thank you very much. Before closing the broadcast, I want to say something. I will leave the links of the papers under the explanation. We don't have time for talking holographic mass solution, and these are in his YouTube channel. You can check there, and mass gravity informations down the explanation part. Thank you very much.
Thank you so much for having me. Thank you, everybody.
See you. Bye bye.